Hi, in this video, we'll learn what linear regression is and how we can use it to make predictions. Linear regression is an attempt to create a linear relationship between two variables that have a correlation. Let's take a look at how this works. Using data, linear regression creates a line of best fit, which is used to make predictions. Data used in linear regression can often be represented using a scatter plot. The x-axis is typically reserved for the independent variable. These are the variables or data points that shape and impact the outcome of the model. In this example, we'll use movie ticket sales. The y-axis represents the dependent variable. This variable directly depends on the independent variable. In our example here, popcorn sales are directly affected by movie ticket sales. This means that there's a relationship between both variables, and that as the value of movie ticket sales changes, the value of popcorn sales is likely to change as well. If we were to populate this graph with data points, we might begin to see a relationship between the variables. As the number of movie ticket sales increases, the number of popcorn sales also increases. This data can be used, along with linear regression, to determine a line of best fit. The line of best fit is the line or linear equation that best expresses the relationship between all the data points. A line is considered to be best fit if it has the smallest total distance from each data point. For example, if we were to try to approximate a line of best fit, this would probably not be the line of best fit because the distance of each data point to the line is pretty significant. Think about it this way. If the line is supposed to represent a predicted result, well then the distance between the actual data and the predicted result needs to be pretty close in order for the line to be best fit. Since the actual results here are far away from the predicted results, the line must not be the best fit. If we attempted another approximation, well, we could see that this is a much better fitting line, as the distance between the predicted results and the actual results are much smaller. And while we can make approximations visually to determine the line of best fit, linear regression is able to determine the line of best fit by using a function. The function is called the least squares method. This method is a statistical formula that is able to determine the total distance between all data points and their respective place on the predicted line. Linear regression starts by approximating a line of best fit and then uses this formula to determine which line has the minimum distance between all the points. And again, our Python libraries can help us with this. Using the least square method, linear regression returns a linear model that represents this line. The linear model often resembles a linear equation that you might have seen in math class, y equals mx plus b. The y value represents the dependent variable. M represents the slope of the linear model. Now, slope determines how steep the line is, or how much a dependent variable changes when compared to the independent variable. The slope can also be referred to as the coefficient or the gradient. X represents the independent variable. And B represents the y-intercept, or the value of y when x is 0. When a linear regression algorithm is called on a dataset, it creates a line of best fit with real values for the slope and the y-intercept. This equation can then be used to make predictions about new data that is input into the model. For example, if we were interested in knowing what popcorn sales would look like if 200 movie tickets were sold, this data point could be input into the linear equation to predict a result. Since x represents the independent variable, we can plug 200 into the model and calculate the value of y. The end result here is 415. This indicates that the linear model predicts that 415 bags of popcorn will be sold if 200 movie tickets are sold. Now, it's important to know that the number that is predicted won't always represent the exact number of popcorn sold. The line of best fit is able to provide realistic predictions because it attempts to fit the data as best as possible. But even in the graph above, it's clear that some of the data points exist above and some exist below the predicted line. So while the results of a linear regression model provide pretty accurate results, they don't always predict the future. Linear regression is quite a popular predictive model. One place where they are frequently used is in car sales. Companies that sell cars often ask for information about your car, like its make and model, and calculate its worth based on previous sales and purchases. Some use linear regression models to help make those estimates about your car's total worth. While linear models are a powerful predictive tool, they do have some limitations. For one, linear regression can only be used on data that has a linear relationship. That means the independent and dependent variables increase or decrease at similar rates. It also works best on data that has a strong correlation. A linear model will not work well or effectively predict values if there's a low or no correlation between the two variables. And lastly, outliers in the data, or the data points that stray away from a pattern, can impact the line of best fit, causing the accuracy of the model to decrease. Let's see what this looks like in our code editor. Now, once you have determined that a dataset has a linear correlation, you can develop a linear regression model. Now, in this video, we'll be working with a dataset that relates the temperature to the number of cricket chirps per minute. We'll need to use a few Python libraries to plot the line of best fit. We'll use pandas and matplotlib, of course. But we've got a new one called NumPy. NumPy will be the one that actually helps us determine the linear regression. First, we'll set the values for x and y. The independent variable is the temperature, and the dependent variable is the number of chirps. Then we'll check to see if there's a correlation between the two. There is a very strong positive correlation. Let's plot this on a scatter plot. On this screen is the code that we use to add labels and a title and plot the scatter plot of x and y. We can definitely see that there is, in fact, a strong positive correlation. As the temperature increases, the number of chirps increases as well. Now what we can do is use NumPy and a new polyfit function to find the line of best fit and create a model equation. This function requires the x values, the y values, and the 1 you see here is denoting the type of equation we would like to use. A linear equation has a degree, or leading exponent, of 1. If we put a 2 here, it would give us a quadratic equation. A 3 would give us a cubic equation, and so forth. But we want a linear equation, so this will always be 1 for now. If we print the model, it will list the values of m and b to create our line of best fit. The m is 1.185, or rounded off to 1.19, and the b value rounds to negative 49.25. So this gives us y equals 1.19x minus 49.25. Let's use this model now to plot the line of best fit. We'll want to set the x values to match the data. So you might be able to look at the data set and see the minimum and maximum values of temperature, but we can also always use the min and max functions. Let's see what this gives us. We can now see that the minimum temperature is 55 and the maximum is 80.5. We'll use these values to set up the x values of the best fit line. We can use the range function to create a range of numbers from 55 to 81. We'll choose 81 instead of 80.5 because the range function can only accept integers. All right, almost done. Now let's determine the y values. This new NumPy poly1d function helps to define a polynomial function. So what this means is that it takes the values of our model and creates a linear equation, just as we did earlier. We can then use it to predict the corresponding y values for the line of best fit. Then we plot the line using these values. All right, there it is. We just completed linear regression using data. You can also use predict to predict specific values. If we plug in 60 into the line of best fit, it will predict that when the temperature is 60 degrees, the number of cricket chirps should be about 22 chirps per minute. The model here is using the x value of 60 and finding the corresponding y value of 22. All right, well, now it's your turn to dive deeper and explore more about these concepts.